Problem number 43. This is a good problem here because it's a combination of 14.7 and 14.8. We want to find the absolute max and min values of this function in the region x squared plus y squared is less than or equal to 36. So x squared plus y squared is equal to 36 is the circle here, but to make it less than or equal to 36, it's this filled in circle. So what are we going to do? We're going to use 14.7 methods on the interior to find the critical points, and then on the boundary, we're going to use Lagrange multipliers for the boundary, 14.8. Okay, so first off, critical points in 14.7. Okay, we need to take the partial derivative, set them equal to 0, solve. The x partial derivative here is 2x minus 6. The y partial derivative is 2y minus 8. Set both of them equal to 0. What do we get? This gives us x is equal to 3. This gives us y is equal to 4. So our critical point is 3, 4. 3, 4. So here is our critical point. And by the way, we should check, is 3, 4 in the interior here? 3 squared plus 4 squared is 9 plus 16 is 25. That is less than 36. This does fall in the interior of the circle. Okay, so we got the critical point. That's one of our possibilities. Our other possibility is that the maximum min could fall on the boundary. So what do we need to do? We're now trying to find maximum values of f of x, y. So max, min, f of x, y, subject to the constraint g of x, y is x squared plus y squared is equal to 36. So now it's a Lagrange multipliers question. So our Lagrange equation, the gradient of f is equal to the lambda times the gradient of g. The gradient of f is going to be 2x minus 6, 2y minus 8. It's equal to lambda times the gradient of g is 2x, 2y. Okay, let's go to a new slide here. So writing it a little bit more explicitly, 2x minus 6 is equal to lambda times 2x. 2y minus 8 is equal to lambda times 2y. Don't forget, we're operating under x squared plus y squared is equal to 36. Okay, how do we solve this system of equations here? Okay, we need to figure out how to solve this. I'm going to try something here, and I hope it works. I'm going to multiply both sides of these equations by something to make their right sides the same. So lambda times 2x, lambda times 2y. I'm going to make both of the right sides of the equations lambda times 2xy. So to accomplish that, I'm going to multiply the first equation by y and the second equation by x. So the first equation becomes 2xy minus 6y is equal to lambda times 2xy. And the second equation becomes 2xy minus 8x is equal to lambda times 2xy. And hey, this is great. So if this is equal to lambda times 2xy and this is equal to lambda times 2xy, well, guess what? 2xy minus 6y must equal 2xy minus 8x. Cancel out the 2xy's, and we are left with negative 6y is equal to negative 8x, or y is equal to 4/3 times x. Okay, so at this point then, y is equal to 4/3 times x. That substitute that into x squared plus y squared is equal to 36. X squared plus 4/3 x squared is equal to 36. X squared plus 16 over 9 x squared is equal to 36. X squared plus 16 over 9 x squared is 25 over 9 x squared is equal to 36. So x squared is equal to 36 times 9 divided by 25. So x is equal to plus or minus the square root of this, which is equal to plus or minus, let's see here, 3 times 6 is 18 over 5. So this gives us two possibilities. If x is positive 18 over 5, y is 4/3 times this. 4/3 times this is going to be, let's see, 72 over 15. I guess I should divide out. Okay, 24 over 5. Yep, that looks right. And if x is negative 18 over 5, y is 4/3 times this is negative 24 over 5. So here's one possibility, 3, 4. We also have the possibility 18 over 5, 24 over 5, and negative 18 over 5, 24 over 5. Okay, so the very last thing for us to do here is we have our list of possibilities is, let's see here, 3, 4, and 18 over 5, 24 over 5, negative 18 over 5, negative 24 over 5. So to finish this problem off, what you would do is that you would take these 3 points and plug them in to this expression right here. So like, you know, we're making a chart here, f of x, y. So f of 3, 4 would be 3 squared minus 6 times 3 plus 4 squared. I'm just plugging in everything into here. Minus 8 times 4 plus 5. The second one, 18 over 5, 24 over 5 would be 18 over 5 squared minus 6 times 18 over 5 plus 24 over 5 squared minus 8 times 24 over 5 plus 5. And then finally, negative 18 over 5 squared minus 6 times negative 18 over 5 plus negative 24 over 5 squared minus 8 times negative 24 over 5 plus 5. Okay, so these don't work out very nicely here, and unfortunately I didn't pre-compute this, and I don't have a calculator. My calculator is my cell phone, and my cell phone is currently filming this, so I can't really easily compute these. So crunch out these 3 values, pick which one's the biggest, pick which one's the smallest for your absolute max and absolute min. I trust you're capable of doing that.